In this video, I will explain the derivatives. There are many types of derivatives. Okay, remember here the derivatives we have polynomial, we have products, we have quotient. Sometimes we have trigonometric. We have also the exponential function. I started each part alone, and we have example. This is like a summary for all types of the derivatives. Okay, first we have polynomial. What is the meaning of polynomial here? The polynomial, here we have two types for the number of the term. Here we have term 1. See, we have one term. Here we have two terms. Here we have three terms. We have 1, 2, 3. Why I say three terms? Because each plus and minus we say one term. Here we have 1, 2, 3. Here we have 1, 2, 3. Here we have many terms. Here we have 4. Here 5. Okay, 1, 2, 3, 4. Okay, and the other types of polynomial, the degree. If you have 0 degree, we say constant. If you have 1, linear. If you have 2, we say quadratic. If you have 3, we say cubic. If you have 4, we say fourth degree. Okay, this is the polynomial. We have two types for number of terms and the second one we have about the degree. Now we will solve it some equation related to the polynomial. Okay, here we have a different types of the questions. Okay, we have question number 3 and 4. We have the same idea. I will solve it question number 4. Okay, f of x. Here we have e to power 5. Here we have e to power 5. Do you have a variable x? Because we must derive it by x. Because f of x, if I write f of y, I derive it for y. If you have f of z, we derive it for the z. Here we don't have x. The derivative for this one, because the constant, this is constant. If I write it for you, len 5, len 6, this is, we say constant, f prime x equal 0. This is for question number 4. Number 3, we have the same idea. Okay, now I will solve it. Question number 6. What we have, f of x equal 7/4 x squared minus 3x plus 12. Here we have three terms. Okay, this is the polynomial. How can you solve this one? We write it f of f prime x equal. Here we have 2. We will subtract it 1. I will say 2. We'll put it down, multiply. Okay, then subtract it by 1. Okay, now 7/4 times 2x to power 1, or we can say x. Okay, minus, here we have 1 minus 1, 0. Remember here, x 1 minus 1 equal x to power 0. X to power 0 meaning 1. Okay, this as a note. Here we have negative 3. This one 0, 12, because it's a constant. Okay, now I simplify this one. F prime x equal, here we can divide it by 2. We have 7/2x minus 3. This is the answer for question number 6. The second part of derivatives is exponential functions. What is the meaning of exponential? What you have it, f of x equal e of x. See, this is, we have exponential functions. Okay, here in the figure, in the graphing for exponential function between y equal to x. See, the asymptotes for this, we have horizontal asymptotes. Horizontal, this one 0. Okay, then we have the function always positive, it's not negative. we cannot find it the exponential function as a negative. Okay, we have 2 to the power negative 1. We will see the number we will very close to 0 for horizontal asymptotes. Okay, now f of x equal ex, that we have the derivative for this one, f prime x equal the same things, ex. Okay, but if I ask you what is the derived for y, if you have it, we have 2x. This is also exponential functions. We say y prime equal the same things, we write 2x, but we write it ln, what is the constant? 2. Okay, this is, we have the 2 example for the exponential. Okay, now here is the equations. You want to solve these equations. Remember, in these equations we have, you want to find the equation of the tangent line and the normal line to the curve of given point. Remember, the tangent line that we have y minus y1. Here we have, we write it line. I can explain this example for you. Line, we have 2 parts, tangent. The second part we have normal. Okay, what is the difference? In the tangent we have y minus y1 equal m x minus x1. For the normal is what you say, y minus y1 equal minus 1 over m x minus x1. This is the difference between. Now how can you derive this one? In equation number 37, we will find the first what you'll do it, you want to find the derivatives. Find derivative. Okay, we have y prime equal, here we have polynomial 4x to the power 3 plus 2ex. Now the second step we will substitute the value of x that equal 0. We substitute here 0, we substitute here 0. Here 0 will go, that we have m equal 2e to the power 0, what equals 2. This is the slope. The third one, we will find the 2 equations, tangent and normal line. Tangent, I will write here tangent, and here normal line. M here equal 2, here m equal, we write it over 1, we will flip it, we have 1 over 2, and here minus. Now I substitute in the equation y minus y1 equal m x minus x1. Okay, now we have y minus, here we have this one 0 2, this is x1, this is y1, minus 2 equal 2 bracket x minus 0. Then we will simplify it, that we have the answer, the last answer. We distributed this one inside, we have 2x, and here 0 will go. Then we have y equal 2x plus 2. To simplify it for this one, we can say in the second page is better, y minus y1, here 1 over m minus here x minus x1. Now we have y minus 2. This one what equal minus 1 over 2 x minus 0. Now the tangent line equal what we have, y minus 2 equal to x. We move it this minus 2x to other side, we have plus. Okay, y equal to x plus 2. This is the equation for the tangent line. Okay, now for the normal we'll do the same things. We'll move it to other side, minus 2 to other side, we have plus 2. Now y equal minus 1 over 2 over 2x plus 2. Now the third types, we have the product rule. What is the product rule for the differentiation? How can you derive this one? Okay, remember here we have the first part and here we have the second part. What I will do, I take this one alone, 3x squared minus 5x, and here ex. See, I will derive each part alone. Here what you have, 6x minus 5. This is as a polynomial. This is exponential what you have, ex. Then I do the cross multiplication. Remember the sister for multiply addition. For divide we will use it in the quotient, we will use it subtract. Okay, we will multiply it. Here we have two terms, we must put the brackets. We have two terms, we must put the brackets. We have one term, so I will not put it. What you have the new equation, we have ex, open brackets, we have 3x squared minus 5x plus ex, open the brackets, what you have, 6x minus 5. Okay, this is the rule for the product rule in the derivatives. Now you want to simplify it more. Ex here and ex here, we can simplify it. We can take a common factor. Ex, open the brackets, what you have, 3x squared minus 5x plus 6 minus 5. Okay, now here we will see the like term. This one we don't have, we keep it the same. Here and here we have the same. Okay, this one and this one we have the same. This one we don't. That we have ex, open the brackets, we have 3x squared plus x minus 5. This is the rule for the product. The fourth one, we have the quotient. We'll do the same things. We have two terms. We have the first term, this one, and this is the second. I will do the same. We have x squared minus 2, and here we have 2x plus 1. Now I'll derive this one polynomial. We have 2x, and this is the constant. Here we have 2. We will use the cross multiplication. Remember, division, we'll use what? Minus. But in the division, we started from down to up. Okay, what we have here, we have two terms. We put the brackets. Here we have two terms. We put the brackets. Okay, here one terms, no need. Here one terms. Okay, what I'll do it, 2x. Then I open the brackets, 2x plus 1 minus. Then we have 2 outside. We have x squared minus 2 over. Here we have numerator and denominator. The denominator squared. We have, this is the rules. We write it 2x plus 1 squared. Now we simplify it. We will make it more easier. Distribute this one inside. Distribute this one inside. Don't forget to distribute with the sign. Here we have a negative. We can see we have 4 x squared plus 2x minus 2x squared plus 4 over what we have here, 2x plus 1 squared. Then what is the answer? We have the same, they have the denominator, we have the same, 2x plus 1 squared here we have 4x squared and minus 2x squared the same, we have 2x squared plus 2, we don't have anything, we keep it the same, plus 2x plus 4. Some person we will do the common factor for the 2 outside, then we have x squared plus x plus 2. Okay, no problems, will not change it my answer. Here we have the trigonometric, most of the students we have confused for the trigonometric. Remember, here we have a note for the letter. We have letter C. If any trigonometry starts with the C, we'll put it minus. Anything will start with S, we have positive. Like cosine, when I say cosine x, what you have? Minus sine. If I say cot, we say minus cos x squared x. Here, letter S, positive. Letter C, negatives, okay? This is very important to understand it for the trigonometric. Now here, they will solve the first one. What we have? Sine, we have multiplication. We have these same things. We will divide it for x squared and sine x. We will do the same. We have 2x here. And sine, we have cosine. Remember, here we have S positive, I put it positive. If I start with the C, anything with the C, we'll put it minus. Then a cross multiplication, and between it what we have, plus. Here one term, one term, one term, one term, no needed for the brackets. Now, the last answer, we have x squared cosine x plus 2x sine x. This is the last answer for the question number 1. Okay, and here we the same. Here we have multiplication, and here we have only tan x. Tan x, we can say 6 squared x. Okay, now here I will solve it for you. Question number 9 or 6, we say 6 we have, because we have ex. It's better for you to distribute it, okay? Or we can make it, this is the first term and this is the second term, as a multiplication. We have many ways to solve this equation, not one way. Some students want to simplify that, we will distribute it, the ex, or we do it, this is the first term, this is the first term, and this is the second terms. I can see ex, e theta. Why I write a theta? Because g theta will derived by theta, tan theta minus theta. E theta, what is the derivative for e theta? We have e theta, the same. Tan, remember here, tan, what we have? Tan 6 squared. We write it 6 squared theta minus theta, like x here we have 1. Then I use the cross multiplication, and between it what we have, plus. Here we have 2 terms, we must put the brackets. Here we have 2 terms, we must put the bracket. Now what is the answer here? We have, say, e theta bracket 6 square theta minus 1 plus e theta tan theta minus theta. Okay, we can say here e theta the same, common factor, we have 6 square theta minus 1 plus tan theta minus 1 minus theta here. Okay, now here, remember here before, we can simplify it more, okay, but in this one I will keep it here. After the second slide I will explain some rules. We must memorize it, because we can say 6 squared minus 1, this is, we say tan squared theta or something like this, or we say minus tan squared theta, and we simplify it. Here we have summary for the rules, okay, that you needed, the formula that you needed for the Pythagorean theorem. Pythagorean theorems, we have 1, 2, 3. What is this? Sine square theta plus cosine square theta equal 1. Also we have 1 plus tan square theta equal sec square theta. We have 1 plus cot square theta equal cosec square theta. See? Now in the previous example we have what? 6 square theta minus 1. What I have here? This one. See? This is, we say, tan square theta. Okay? In trigonometric you need more formula that you use it for the sine 2 theta and cosine 2 theta. Sine 2 theta we have only one formula, 2 sine theta cosine theta, and cosine 2 theta we have 3 formulas, one for sine, one for cosine, one for sine and cosine together. The first one we have cosine square theta minus sine square theta. The second one we have 1 minus 2 sine square theta. The third one 2 cosine square theta minus 1. Okay, this is, we'll use it when you after derive we will simplify the function for sine and cosine. We will use these formulas to simplify your equation. Okay, thank you for listening. I hope in this video I summarize all parts of derivatives.